Water is necessary for survival in Stationeers. You drink it, it waters your crops. It is also a reagent for the composter. In the early game, you will mine ice from the ground and shove it into an ice crusher. You can also send rockets to space to mine it. However, once you have an automated greenhouse, a renewable automated source of water is combustion of alcohol and oxygen. The pipeline is as follows. Divert some crops into a fermenter, mix the resulting alcohol and polluted water with oxygen, react it in a combustor, filter the output, and condense the steam. One complicating factor is that when alcohol evaporates, it turns into methane because there is no corresponding gas. In order to prevent this, you will want to pressurize the output pipe connected to the fermenter. A straightforward choice is to pressurize it with oxygen. You will need to have oxygen in the mix to use the combustor anyway. The output of the fermenter includes liquid alcohol and polluted water. In order to prevent the liquid alcohol from evaporating into methane, I like to use a pressurant valve to preload 600 kilopascals of oxygen into the liquid pipe. The next step in the process is to feed this into the combustor. However, the combustor only accepts gas pipes as input. The easy way to solve this problem is to use an expansion valve. Future Bob here. Stationeers added a liquid input to the combustor in early July, and I haven't allocated time to investigate its mechanics yet. Unfortunately, using an expansion valve to directly attach the liquid pipe to the gas pipe is a good way to burst the gas pipe. Instead, I recommend using a liquid volume regulator before the expansion valve that is controlled by an IC to ensure that the gas pipe does not overfill with liquid. In my setup, I configured the liquid volume regulator to 0.07%, which is so small you will need a labeler to enter the value. But you can play with this a little to alter the duty cycle. In my MIPS code, I use a simple test to turn the regulator on if the volume of liquid divided by the volume drops below 0.02. That way we have fuel to burn, but not so much that the pipe will start creaking. The gas pipe between the expansion valve and the combustor will also need to be pressurized to prevent the alcohol from evaporating into methane. I found that 2 pressure regulators set to 300 kilopascals could keep the pipe pressurized as the combustor was pulling from the pipe. The output of the combustor is a mix of carbon dioxide and water, as well as the polluted water. You will also see some residual alcohol and oxygen that did not completely combust. If at any point you let your alcohol evaporate, you will also see some methane and pollutant. This gas will be quite hot, greater than 1200 Celsius. The polluted water will be evaporating into steam. The next step is a filtration device to separate the steam from the remainder of the gases. Some of the polluted water will end up in the unfiltered output, still in the process of evaporating into steam. Route that hot waste gas into your exhaust gas chiller system to harvest the carbon dioxide and recover some of the oxygen. There will also be some steam that evaporated from the polluted water, but it should not be enough to cause stress on the pipes, and your core gas filtration loop can recover it. Now the steam that comes out of the filtered output of the filtration device must be condensed. Since I am on Europa, this is quite easy. Pumping a couple of liters of steam through a medium convection radiator can dump almost 17 kilojoules of energy into the atmosphere. While the output side of the condenser in my setup has dropped to 14 Celsius, this is a very transient state. Once it gets pumped into the condensation pipes, the act of condensing from steam to water increases the temperature of the remaining steam. I use a software proportional integral controller in an IC to manage the steam chiller. Since my target temperature is 50 Celsius, it actually ends up pumping steam out of the condensing pipes and back into the buffer pipes for another pass through the radiator. The condensing water is removed by a condensation valve and passes into the liquid water pipe network. Now this water is still warmer than we would want to use in our greenhouse, so a second chilling step is needed. I decided that running the hot water through a medium convection radiator was just asking for ice-ruptured pipes. Instead, I use a large direct heat exchanger between the water pipe and a small gas reservoir. The reservoir is chilled by a medium convection radiator behind a valve and drained by a pump. Since I am on Europa and the atmosphere is pure oxygen, I can use that for the buffer gas. And as the gas is warmed by the hot water, I can siphon off some of it to pressurize the alcohol pipes feeding the combustor. If I try to use this as the only source of oxygen for the system, the minus 140 Celsius replacement gas pulled into the buffer drives the temperature of the buffer below 0 Celsius, which risks forming ice in the liquid water pipes, so I have to use some O2 from the greenhouse. Since you are probably on a different planet than Europa, your steam condensation strategy will have to be different than mine. Mars will be similar. Space will probably involve a large extendable radiator. Vulcan, you're going to need some kind of phase change chain or air conditioner chain. An important thing to keep in mind is that running any step in the chain at full speed will likely cause problems. Running the filtration at 100% will probably accumulate steam faster than your condensation subsystems can chill it. Running the combustor at 100% will probably overload the pipes leading to the filtration or drain the input so much that alcohol starts evaporating into methane. Running the fermenter at 100% will probably fill up your alcohol buffer faster than the combustor can burn it. So it is worthwhile to use some MIPS scripts to idle the different components if the input or output goes out of bounds. For the fermenter, set the mode to idle if you already have enough alcohol in the buffer. For me, I chose 30 liters out of a 460 liter buffer. For the combustor feed, turn on the liquid volume regulator when the liquid volume inside the gas pipes feeding the combustor drops below 0.2%. For the combustor itself, switch the mode to active if the pressure input is above 240 kilopascal to keep the alcohol from evaporating. The ratio liquid alcohol of the input is above 0.1, and the pressure output is below 3000. This can be controlled by an IC inside the combustor. I personally included the cybernetics for the previously mentioned liquid volume regulator in the same IC. For the filtration, switch the mode to active if the pressure input is above 600, the ratio water output is below 0.002. This prevents the pipes from groaning. The pressure output is below 2000, so don't overpressurize the steam buffer. And the pressure output 2 is below 8000. Don't overload the exhaust gas buffer. I also included logic to check the amount of water in the liquid water storage to turn off the filtration if it gets over 10% water by volume. You could probably set this as high as 95% if you like a larger stockpile of water, or maybe your water storage system total volume is not as large as mine. You may ask yourself, what do I feed into the fermenter? The answer is corn. While I have not tested every kind of crop, everyone I did test produced alcohol and polluted water at the same ratio, but differing volumes. Corn was the most productive. If your greenhouse produces different stuff, you are not doomed. Just feed it whatever you have available and you will get alcohol. I applied some cybernetics to manage the process. The first step was a MIPS script that sampled a logic memory to see if the fermenter feedstock buffer was full. If it was not full, I load the logic sorter with instructions to divert corn into the feedstock buffer. The next step on the corn's journey was a stacker with mode set to logic. If the stacker's import slot was empty, then I set the previously mentioned logic memory to 1 so the sorter knows to feed me some corn. If the fermenter's import slot was empty, I use setting equals 1, output equals 1 to send a single ear of corn from the stacker to the fermenter. While I have omitted details for a couple of support systems, you should now understand how to use the fermenter to provide your base with a renewable supply of water.